before. Um, right. So in this problem, what I did is I just, gave you essentially a drawing where, it was just simply the, an electron orbital level diagram where it was just like the boxes or different, orbitals, and then it's labels on top, and then it has, the electrons, up or down spin, and just simply asking you to identify the element or ion in these cases. And so if we look at this first one, right, it tells us that it's a ground state atom. We have a configuration rate of 3s2 and then 3p4. And so if we look at that, right, 3p4 would then put us at sulfur right here, right? Because 1, 2, 3, 4 in that case, right? So that becomes sulfur. If we look at B, right? So it says an atom in an excited state. So the thing to look at here, right, is that the 2s, it's not completely filled, right? It has only one electron here. And so that's where the electron was excited out of the 2s. And we can see then in the 2p, right, that it has an electron there, right? It's not completely filled. And so then, presumably the electron was excited into the 2p state in that case. So, the correct ground state configuration in this case would then be, right, this guy right here. Right, that right where we have 2s2, 2p3. And so if it's 2s2, 2p3, right, we just go here and look at it, right, 1, 2, 3, nitrogen in that case. For C, right, a ground state ion with a charge of -1. So that's telling us, right, if it has a charge of -1, it has one extra electron. And so looking at it, right, we have 4s2, right, and then we have 4p5 in this case. And so that tells us then that in the ground state, right, what we should have is 4p4 in that case, right? So 4p4, we go down to the fourth row, we're right here, right? We're at 1, 2, 3, 4 in this case. And so that should be then selenium, right? So the element is selenium. We know it has a charge, right? So it has to be selenium -1 in that case. So, right. So that's the process, right? So when you have any kind of charge, you have to either, take away or add electrons as appropriate. If you have, an excited state, just make sure, you can just go through and then take the electron out of the excited state, right? Put it back down into the ground state where it belongs, and then look at the electronic configuration there, and then just look at the periodic table, right? And you can just work your way through that, right? I mean, the easiest way to always like think about the periodic table is that these guys are the S block, right? This is the P block. This is the D block, right? And then this is the F block right there, right? So if the valence electrons are in any one of those, all you have to do is just work your way through that, through that group, right? You can, essentially disregard like all the other core electrons in that case, right? All you have to do is make sure you're right in the right row and be like, okay, right, valence electrons are in the d orbital. There's 6 of them. I'm like, okay, and some, the 3 is the 3d, right? And so I'm like, okay, well, if it's 3d, it has to be in the fourth row, right? And you're like, there's 6 of them. You're like, okay, well, 1, 2, 3, 4, 5, 6. Okay, right, that's iron, right? The Fe. So, that's the easiest way to do it, is just segmenting out what the different parts of the periodic table tell us.